Okay, in this next example, we actually have both of the things we want to have happen. We have an even power secant, so we could strip that away and work this problem out as integral of tangent to the third, right? And we could work that out and get an answer with basic substitution there. And that's fine. But this one here, I want to do the other way. I want to show you an example of pulling that off, because what if this was a secant cubed or just a secant? Okay, then that approach wouldn't work. So here we have the odd tangent. So when we have an odd tangent, we want to pull off a tangent secant. Again, we have an even secant, so we could pull it off. And this would just be the integral of tangent cubed. And that would be fine. That would be 1/4 tangent to the fourth x plus a constant. And that's perfectly fine. But I just want to show you an example of doing it the other way. Okay. So here I'm going to pull off a tangent secant as a factor, and then work with what I have left. So I have tangent squared x. So I'm taking a tangent away from the tangent cubed and a secant away from the secant. So I have tangent x secant x. Go with my dx. All right, and then this tangent squared, we're going to use the identity, right? And replace that tangent squared with secant squared x minus 1. Right? Secant squared x minus 1. Right? It's just using that tangent squared identity. Right? Tangent squared equals secant squared minus 1. So tangent squared is equal to secant squared minus 1. Or the alternative version of it, 1 plus tangent squared equals secant squared. Okay. So that's what we're making use of here. That allows me to turn the tangent squared that's left over into a secant, so that everything that's left now has a secant on the inside. So we'll have integral multiplying that out of secant cubed x minus secant x. And then we still have that tangent x, secant x sitting around with our dx. All ready to take on and act now. All ready to take on and become what it needs to become when we do our u substitution. U equals secant x. So that we have just what we need for du. Tangent x secant x dx. So that this just becomes the integral of u cubed minus u du. And we work it out. Right? 1/4 u to the fourth minus 1/2 u squared plus a constant. And then we just substitute in. There for secant. 1/4 secant to the fourth x. I'm sorry, 1/4 should not be in parentheses there. All right, 1/4 secant to the fourth minus 1/2 secant squared x plus a constant. Okay. Now, a little challenge for you would be to show that that's the same. If you want to kind of play around with some trig identity, to show that that's the same as the 1/4 tangent to the fourth x plus a constant that I would have gotten had I done it the other way. Had I done this the other way, show that that's actually going to be the case. Might be something kind of interesting to try. See if it does work out. It should, right? Because here that would have been using this, and we'd have integral of tangent cubed, which would be 1/4 tangent to the 4th plus a constant. So if you're trying to do that, you may need to do some borrowing of constants. So if you need a 1 or a 1 to pop out somewhere to carry a substitution through in one of those, you'd want to do that. But the main point of this example here isn't that. It's just to show you that when we have an odd tangent, we can strip 1 off to go with our secant. Okay, convert the remaining tangents, which will now be even powers, into secant squared minus 1s. Simplify the arithmetic, the algebra there, and then integrate the remaining part using your substitution. That gets you to an integral of powers. Use your power rules, substitute back, and we work out our problem.